You ever just look up at the night sky? I mean, really, look at the moon. It's just always there, right? Our silent, steady companion on this journey through space. It feels like such a constant, doesn't it? But what if we kind of nudged that relationship a little? What if our silent partner got just a bit closer? That's what we're going to dig into. And trust me, the answer is way more dramatic than you'd ever guess. All right, so let's put some numbers on this. We're not talking about some crazy end of the world scenario. No, no. Let's just say the moon scoots in a little bit from its usual 384,000 kilometers away to, say, 340,000. That's only a 10% shift. Sounds pretty minor, right? Well, as we're about to see, even that tiny change would have absolutely massive consequences. So where would we see the first ripple effects? Well, the changes would start immediately, and they'd be things you could see with your own eyes and feel in a huge, huge way. First off, just the view. I mean, wow. A moon that's 10% closer, it would look about 20% bigger in the sky. All those craters and seas that are usually just faint smudges, they would suddenly pop with incredible detail. It would be just an absolutely jaw-dropping sight every single night. And of course, with that bigger size comes a whole lot more light. We're talking a full 44% brighter. It would just bathe the night in this brilliant silvery glow unlike anything we see today. But, you know there's a but, right? This beautiful new nightlight would have a seriously dark side. Yeah, this is where that first domino starts to fall. See, so many ecosystems are perfectly timed to the rhythm of light and darkness. Nocturnal hunters like owls, they'd suddenly have it too easy. Their prey would be lit up like a spotlight. That throws the whole predator-prey balance out of whack. And think about things like coral spawning, which are literally timed to moonlight. Complete chaos. Or baby sea turtles who use that faint glow on the horizon to find the ocean. They'd just be completely lost. And look, those changes to the ecosystem are huge. But as big as they are, what we see in the sky is nothing, literally nothing, compared to the raw, brute force that would be unleashed in our oceans. Okay, this is where the physics gets really cool. The moon's pull on our tides, it isn't a simple one-to-one thing. It actually follows something called an inverse cube relationship. So what does that mean? It means our little 10% shift in distance creates a tidal force that's about a third stronger. Now, one-third might not sound like a world under, but for our oceans, believe me, that is a colossal shift in energy. And the real-world impact of that energy, it's just staggering to think about. We're talking daily tides surging meters higher than they do today. Major coastal cities would be dealing with serious, routine flooding. Storm surges from hurricanes wouldn't just be bad, they'd become these continent-swallowing monsters. Our coastlines, gone. Eroded away in decades, not centuries. And all those crucial wetlands just wiped out, forcing hundreds of millions of people to flee inland. It's a complete reshaping of our world. Okay, let's go a layer deeper. Beyond the coasts, this new, tighter gravitational grip would start to fundamentally mess with the very rhythm of our planet. So right now, the moon's pull on our tides creates friction, and this whole process very, very slowly slows down the Earth's spin. It causes our day to get longer by about 1.7 milliseconds every century. I mean, you'd never notice it, but with a closer moon and way stronger tides, that whole process would hit the fast-forward button. Our days would start getting measurably longer, not over thousands of years, but within a few centuries. Here's another thing. The moon is basically our planet's anchor. It's the whole reason Earth has that steady 23.5-degree tilt, which is what gives us our regular seasons. A closer moon would grip that axis even tighter, locking it in place. Now, that might sound good, maybe fewer ice ages over time, but again, it's another fundamental rhythm of our planet being completely rewritten. All right, let's go even deeper now, because the moon's gravity doesn't just pull on water. Nope, it pulls on the entire planet. And turning up the volume on that pull would have consequences that start deep, deep inside the Earth's crust. So we all know about ocean tides, right? But did you know there's also something called a solid Earth tide? It's true. The actual ground beneath your feet is rising and falling by several centimeters every single day because of the moon's pull. It's like the whole planet is constantly, gently breathing. So what happens when you take that gentle breathing and make it much more intense? Well, first, you get way more internal friction inside the Earth. More friction creates more heat in the mantle, and over geologic time, that extra heat and energy could start to Well, lubricate the tectonic plates. This could lead to more frequent earthquakes, more volcanic eruptions. Our planet would become a much more geologically restless place to live. So, as we start to wrap this up, it's important to remember that this whole what-if scenario isn't just some crazy science fiction. In a way, it's actually a look back into our own planet's super chaotic past. And man, is it a powerful reminder of the incredible balance that makes our world possible. Believe it or not, Earth has actually been there, done that. Right after it formed, the moon was incredibly close, maybe only 25,000 kilometers away. Back then, a day was just 5 hours long. And you had these massive tides of molten rock and water, hundreds of meters high, just sweeping across the planet. The world we have today, our 24-hour day, our stable climate, that's the result of the moon slowly drifting away over billions of years. Now, what if things went the other way? What if the moon got way too close? Eventually, it would cross a point of no return. It's a real thing. It's called the Roche limit. Basically, it's that invisible line in space where a planet's gravity becomes so powerful, it literally rips a moon apart. And the result of crossing that line? The moon would be completely shredded into trillions of pieces. And those pieces would form a stunning, shimmering set of rings around Earth, just like Saturn's. I mean, what a sight that would be. But in exchange for that beautiful view, we would have lost the very anchor that keeps our planet stable. Our world would be plunged into chaos. And that really gets to the heart of it all, doesn't it? This delicate dance between the Earth and moon, it's not some cosmic accident. It's a perfect equilibrium, a balance that's been negotiated over billions and billions of years. It's the relationship that has shaped everything about our world, and even our own evolution. So the next time you look up at that familiar face in the night sky, just remember, its distance isn't just a number in a textbook, it's the very anchor that makes our world possible. It's not just a pretty light up there, it's a fundamental architect of our home. And that is definitely something worth thinking about.